Hello. A lot of Farnborough Year 10 was set trigonometry as one of their tasks last week. A number of people have just requested that we put a bit of a video together just to give them a little bit of a help with the method. You have done it before, but it's just about getting back into that practice. So we're going to go through a couple of examples of trigonometry in right angle triangles today. We're going to look at how to work out missing sides and how to work out missing angles. It's very much a process. You follow that process step by step. We should be able to get to our correct solution. So first bit, there is our right angle triangle. If you see a right angle triangle in your GCSE paper, probably it's going to be one of two things. Could be a few others, but probably going to be one of two things. If it's just asking about the sides of a triangle, it's going to be Pythagoras. So if no angles involved, if you say it gives you those two sides and asks for that one, or those two and asks for that one, etc., etc., it's going to be Pythagoras. If an angle is involved in any way, so it's either asking for an angle or it gives you an angle on one side, that's where trigonometry comes in. So trigonometry is just a way of working out missing sides and angles in right angle triangles. The stuff that we're going to deal with is only in right angle triangles. There are other bits of trig that are coming up, so sine rule, cosine rule, etc., that allow you to work it out in non-right angle triangles. So doesn't matter whether it's going to be a angle you're looking for or a side. The first steps are exactly the same. You've got to be able to label up the triangle. So we have our right angle there, indicated by the square. We have the angle that either we're looking for or the one that we're given there. So we've got to label up our three sides. The three sides are the hypotenuse. Hypotenuse is always going to be the longest side. You've got the opposite and you've got the adjacent. So those are our three sides. You can write out the words in full if you want. I always just use the three letter kind of abbreviation. You can just use H, O and A if you wish as well. So first of all, hypotenuse, it's the longest side. The longest side in a right angle triangle is always going to be opposite the right angle. You can test that for yourself. If you want to draw some right angle triangles, measure the sides, the hypotenuse will always be the longest, so it's always going to be opposite the right angle. The second one we're going to label up is the opposite. Opposite is exactly as it sounds. It's opposite where the angle is. So the angle's there, so my opposite side is going to be there. We've only got one side left now anyway. Adjacent to means next to. So the side that is next to the angle is going to be my adjacent. So that's the first skill that you have to practice. Take your right angle triangle. So it may not look like that. It may be a different way around. So it could be like that. So there's my angle. There's my right angle. So in this one, hypotenuse, opposite, adjacent. It could look exactly the same, but with the angle in a different place. Obviously that then changes everything. Hypotenuse is still opposite the right angle, but now the opposite is going to be there and the adjacent is going to be there. So that's your first skill, just practicing labelling up your hypotenuse, your opposite and your adjacent. If you don't get them labelled up right in the first place, then your whole process will fall down. Once we have labelled up, we then need to start thinking about which of the three trigonometric functions we're going to use. So on your calculator you have sine, cos and tan, and we're going to go in to greater detail when we're back at school about where they come from, how they work, etc. But depending on which side you're given, you may need to use sine or cos or tan. So to remember that, there are various different ways. The first way is just remembering SOHCAHTOA. So SOHCAHTOA, the S stands for sine, the C stands for cos, the T stands for tan, and then the OH, AH, OA refer to our sides, as we said before about the opposite, the adjacent and the hypotenuse. So that's one way. There is various acronyms that you can remember as well. I was always taught salt on hot chips and hot toffee on apples to help me remember this, but there's lots of other acronyms out there as well. So we're just going to take a right angle triangle now, and I'm going to give us two sides, and we're just going to go through how we select which bit of sine, cos or tan we're actually going to use. So this is my right angle triangle, just get rid of that arrow there. If I'm given this as 10 centimeters and I'm given this one as 8 centimeters. So first task, label sides. Always your first task, label the sides. So hypotenuse, opposite the right angle. So there's my hypotenuse. I'm just going to put in a circle just to remind me that's just a label. There's the angle. So opposite the angle is the opposite. And finally, that is the adjacent next to it. So I've labelled my three sides up, my hypotenuse, my opposite and my adjacent. I'm now going to tick tick cross. Tick tick cross is just a way of working out which of the sides you're going to use and therefore which of the sides you're not going to use, and that allows us to work out whether it's sine, cos or tan. So anything I'm given I am going to tick, or anything I want to find out I am going to tick. So I'm given the hypotenuse, so I'm going to tick it, just get the light off there. I might just turn the light off on the camera just to help me a little bit. So there is the tick on the hypotenuse. I'm going to tick the opposite as well because I'm interested in the opposite. I'm going to cross the adjacent because I'm not interested in it. So anything you're given, tick, or if you're trying to find something out, if it said can you find out the opposite, you tick that as well. We'll show that in a second. I'm then going to write out SOHCAHTOA. So salt on hot chips and hot toffee on apples. So I still use that acronym now just to help me remember. Acronym, mnemonic, whatever you call it. I'm just going to divide into three just to make sure sine, cos and tan are separated up. I'm now going to look down the line and think, what one am I going to use? Well, I can only use things with the O and the H, the opposite and the hypotenuse in it. So anything with an A, adjacent, I can cross out. So I can't use cos, I can't use tan. So in this case, I'm going to be using sine to try and work this out. Okay. There's a reason that I've put that as a little triangle like that, and that will become a little bit more obvious in a minute. So I'll just do one more like that just to check that we can do this properly. So there's my right angle triangle. This time I'm going to say I'm looking for that one. I'm giving that as 50 degrees and I'm giving that as 10 centimeters. So again, first step, I'm going to label everything up. Right angle. Opposite the right angle is the hypotenuse, the longest side. There's the angle. Opposite the angle is the opposite side. And then this one here is going to be the adjacent. So I've labelled up correctly, double check it, I'm happy with that. I'm now going to tick tick cross. So I'm interested in the adjacent because I'm given it, it tells me it's 10 centimeters. I'm interested in the opposite because it's asking me to find the opposite. I'm not interested in the hypotenuse, so I'll cross that one out. I'm now going to write down my SOHCAHTOA again. So salt on hot chips and hot toffee on apples. Split it up. So this time anything with a H in it I'm not going to be able to use. So cross, cross. So this time I'm just left with tan. Tan is the one that's got the opposite and the adjacent, so to solve this problem I would have to use tan. Right, so that's our first two steps, and it's not going to matter whether I'm using Trig to find a side or an angle. Those first couple of steps, labelling up and then tick tick cross, that's going to be your way of working out which bit of Trig to use. So we then come on to a couple of questions. So our first two, we're going to use Trig to work out a missing side. So there's my right angle, so I'm going to label up. There's my hypotenuse, there's the angle, so there's my opposite, and there's my adjacent. Just zoomed out a little bit there. Just put the light back on, I think, now. So tick tick cross on this. So I am definitely interested in the adjacent because that's the one it's asking me to find. I am definitely interested in the opposite because I'm giving it as 10 centimeters. I'm not interested in the hypotenuse. So Sokotoa, salt on hot chips and hot toffee on apples. So sorry if you're getting me bored of me saying that. I said it's just the process where I'm doing a trigger question. I will always say it to myself just to make sure I've got it right. So O and A, anything with the H are cross out, so I can't use cos and I can't use sine. So the one that I'm going to have to use this time is going to be tan. So I'm now looking for the adjacent. That's why I've now wrote these out in little triangles already. I mean, you can write it out as a full triangle if you wish, same as you've seen for speed density or all those compound measures. So tan, we've got adjacent, and we've got opposite. Now the reason in a triangle, same as for speed, distance and time, things that are above each other, that's going to be some division. So it would be opposite divided by tan, it would be opposite divided by adjacent. If they're next to each other, you're going to multiply. So now we're just going to find out what we're looking for. Well, we're not looking for the angle, we've got it, so that's fine. We're not looking for the opposite, we've got it. We are looking for the adjacent, so I'm going to cover over the adjacent. What I'm then left with tells me how to work out this particular problem. So covering over the adjacent leaves me with opposite on top divided by tan on bottom. So I'm going to write that out now as a formula. So adjacent equals opposite divided by tan of the angle. And as we kind of move through trig, we'll start learning a bit more why this works, how it works, but sine, cos and tan belong, they are functions of that particular angle. So final step, I'm going to put some numbers in. So the opposite, I'm told, is 10 centimetres. I'm always going to use this as a fraction rather than just write divide, because I'm going to type it as a fraction in my calculator. So 10 centimetres divided by tan of the angle. So that's tan. When you press tan on your calculator, it will automatically open a bracket up. The only number I've got left is 35 anyway, because I've used 10. So I'm going to put this into my calculator. So here's my calculator. So 10, press the fraction button, which is just up there. And then we've got tan 35. Make sure we close the bracket there. It's a good habit to get into. Press equals, and it will tell me that the adjacent in this particular case is going to be 14.28 centimetres. Okay. Right, similar, we're going to again label up. There's my right angle, so there's my hypotenuse, there's my angle, there's my opposite. So this means this one here is going to be my adjacent. So I've labelled up correctly, I'm perfectly happy with that. Again, I'm going to tick across. So this time 6 centimetres the hypotenuse, so definitely interested in that. I'm looking for the adjacent, so I'm definitely interested in that. Opposite, this case I'm not interested in. So salt on hot chips and hot toffee on apples. So this time anything with O I can't use, so I can't use sine, can't use tan, I'm left with cos. So again, I'm going to write that out as a full triangle, so cos adjacent, hypotenuse, put it into a triangle there. Again, we have divide if they're above and multiply if they're next to each other. So adjacent is the one I'm looking for, so if I cover that over, this time cos and the hypotenuse are next to each other, so I'm going to write that out as a formula. So adjacent equals cos of the angle multiplied by the hypotenuse. Final step, put in some numbers in. So cos of the angle, so cos belongs to 70 degrees, so put that in, multiplied by, make sure you do close that bracket. If you don't close the bracket there, it will cause issues this time. Times by the hypotenuse, which is 6. And we're going to get our calculator. So we've got cos of 70, close the bracket up, times by 6, and that gives us 2.05 centimetres. Okay. So that's your basic process to find a missing side in our right angle triangles. Last two. This time we come to finding a missing angle. You'll find as we go through this, you will always have to divide one number by the other because of the ways the triangles are put together, and then there is a further step right at the end just to turn this back into an angle. But to start with, we still do exactly the same process. So there's our right angle, so that's the hypotenuse. There's the angle, so that's our opposite, and there's our adjacent. Again, we're going to tick, tick, cross, tick, tick on the two I'm given, cross on the hypotenuse because I don't have any interest in it. Salt on hot chips and hot toffee on apples. Anything with H we get rid of. So it's going to be a tan type question. So writing out my triangle, tan, opposite, adjacent, that's times, that's divide. Because it's the angle I'm looking for, and it'll be the same on whether it's sine, cos or tan, the angle you're looking for, you always end up covering over the bottom left because that's where sine, cos and tan are in my triangles. So you are always going to end up dividing when you actually work out an angle using trigonometry. So writing that out, tan of the angle is equal to opposite divided by adjacent. So I'm going to put some numbers in there. Opposite is 3, adjacent is 6. Use my calculator, otherwise 3 divided by 6 is 0.5. Now this is where some people go slightly wrong. So the tan of the angle is 0.5. To me, it would strike me as that doesn't sound right. It's too small. It's not likely to be an angle where you've got a side of 3 and side of 6. That's because at the moment it's a function of the angle. It's the tan of the angle. So I know tan theta, tan of the angle, is equal to 0.5. Now on your calculators, on scientific calculators, when you press sine, cos or tan just above them, it's not very easy to see there, you've got sine to the minus 1, cos to the minus 1, tan to the minus 1. That's the inverse function. It basically gets rid of that particular function. So I know tan of the angle is 0.5, so to find out what the angle actually is, I'm going to type in tan to the minus 1. So to do that we press shift and then tan, so tan to the minus 1 comes up of that answer, which is 0.5, and then the calculator does its business and turns it back into an angle. So tan to minus 1 is 0.5 gives me 26.6 degrees. Now you can do that in one foul swoop, which is how I'd personally do it, but if you break it down that's fine as well. So into my calculator I would have typed, rather than do this to start with, I just would have done tan to the minus 1 of 3 divided by 6. So just put your fraction in straight away. So if we do that, tan to the minus 1 of 3 over 6, make sure you close your brackets as ever, and that obviously gives us exactly the same answer. It's just a slightly more efficient way of doing it. Right, so one last one. Again, we've got a right angle triangle, so we're always going to start by the same process of labelling. Hypotenuse opposite the right angle. That's going to be our opposite there, and that's going to be our adjacent. So ticks go on the opposite and on the hypotenuse, cross and goes on the adjacent. Sokotoa, salt on hot chips and hot toffee on apples. So I'm going to select anything H and O is fine. Can't use anything with the A, so I can't use cos, can't use tan, so I'm left with sine. I said on the previous question, I know it's going to be divided because there's my sine, but my triangle anyway, sine opposite hypotenuse, divide that times that, cover over, I've got opposite on top, hypotenuse on bottom. Make sure you don't suddenly flip them, or it really does matter what order you're dividing in. So you can't do hypotenuse divided by opposite, it's opposite divided by hypotenuse. That's why I model it as using a fraction, because then they're in the right place. So sine of the angle equals opposite divided by hypotenuse. So breaking it down into two steps, that would be opposite is 42, hypotenuse is 48. So we use our calculator, otherwise 42 divided by 48 gives me 7/8, 0.875 if you want to convert it. Either way is fine. And so I know sine of the angle, sine theta equals 0.875. So same as before, to get rid of sine, we can do the inverse. So the angle is going to be sine to the -1 of 0.875. Close our brackets up, so we get an answer there of 61.04 degrees. Again, personally, I'd do it all in one foul swoop, so I know this is my formula here. So my angle, my missing value that I need, is going to be sine to the -1 of 42 over 48. I say make sure you don't flip them around. The most common mistakes people are making that I've seen is putting the 48 top on 42 on bottom. In this case, actually, it wouldn't work, because if you tried to do that, shift sine of 48 over 42 give you an error, because sine only runs between 1 and -1. So 48 divided by 42 gives you a value bigger than 1. Right, hopefully you found that useful. I'm going to do a few more videos with the other kind of trigonometry topics that are coming up. Any other questions, contacts over, show my homework over the email, etc, etc.